Hi everyone, in this video I'm going to be working through some questions from a grade 8 past paper. I hope this helps. Let me know if you have any questions or anything in the comments and I can go through those too. So jumping straight into the first 10 questions, we've got multiple choice questions. So we can see they start off with this first question. They love asking questions like this because they try to trick you. So x, add x, add x. So what you need to try to remember is when you're adding x's, so if we take, for example, let's just say x, add x, that is just going to be, okay, it's like an apple, add an apple means I've got two apples, so I've got two x's. Whereas the other one, this is where they like to trick you, is if you are multiplying x's, so if you're going x times x, then that would be x squared. Okay, so that's why you need to be careful with this one. So first of all, let's just try to do it without looking at the answers. So x, add x, add x, so 3x's. Okay, so you can see this is B. They wanted us to choose A, that's why they put it in there, to try trick us. Obviously, it's not going to be this one because we don't have any x3s, and there's no reason for it to be 4x. Okay, so it has to be that one. Next up, question 1.2, we've got a BODMAS question. So we just got to make sure we do the right order. So we've got to do brackets first. So 12 divided by 2 would be 6. Then we do the next bracket. 6 times 3 is 18. And then minus 3. And then pretty simple to work out then. So 6 add 18 is going to be 18 add 6 is 24. Take away 3 is 21. Okay. So again, with these multiple choice questions, I would say try work it out first before you even look at the options, because sometimes the options are there to try to trick you. Next up, we've got 1.3, which is an equivalent fraction question. So if you struggle with this kind of thing, that's what you need to be looking at. So it's equivalent fractions. So equivalent fractions means both sides have to be, you do the same thing to both sides. So if we write this just a little bit bigger, just so we can see it, we've got 2 over 7 is equals x over 21. Okay, so these fractions are equivalent, so that means whatever I do to the top, I have to do exactly the same to the bottom. So let's see, at the bottom, how did I get from 7 to 21? So it's always what did I times or what did I divide? So here I went 7 times 3 would give me 21. And because they're equivalent fractions, because they've got that equal sign, you always do exactly the same at the top. So 2 times 3 would give me 6 at the top. Okay, so the value of x would be 6 for this one. So nice and straightforward. Just always work out what can I do to the top and the bottom. It's either going to be what can I times or what can I divide. If you were to work backwards with this one, you could have gone 21 divided by 3 gives you 7, and 6 divided by 3 will give you 2. Okay, so whichever is easy for you. In this case, timesing was easiest for us to figure this out. Question 1.4, the next term in this sequence is, let's see, so 1, 3, 9. So we can't really add anything, because if I add 1, it's going to be 1 add 2 will give me 3, and then 3 add 6 will give me 9. That doesn't really work out for me. What you're going to have to do is try with these, always test. So can I add anything? Is it a square number? So let's see. 1 squared is 1, and then 2 squared is not 3. Okay, it's not square numbers. Can I times anything? So let's go 1 times 3. Let's test this. Times 3 gives me 3. 3 times 3 gives me 9. Okay, so that looks like it will work then. You can also always check, this one obviously it is timesing by 3, but you can also always check, is it a cube number? So 1 cubed is 1, 2 cubed would be 8. Okay, so that doesn't work. So this one we are going to be timesing it by 3. So the next term is 9 times 3, which is going to be 27. Okay, so you've just got to play around with these, see what works. Is it adding? Is it subtracting? Is it timesing? Are they square numbers? Are they cube numbers? Then question 1.5, the value of this cube root of 125. So you do have calculators on this paper, so you could just plug that straight into your calculator. But just so you know how to do it without it, is you would have to say what number can we times by itself 3 times to get to 125. So let's just test. So if I went 5 times 5 times 5, let's see. So 5 times 5 is 25, times 5 is 125. Okay, so that is going to be our answer. The cube root of 125 is 5. So what number can I times by itself 3 times to get to that number? The negative's not going to work because then we would end up with a negative root or a negative number under there. 25 is not going to work because that's going to just 25 times 25 times 25 just gives you a massive number. So it doesn't give us 125. And the same for 15. Just doesn't give us 125. Okay, if you are struggling with that, remember then you need to have a look at cube numbers to revise that. And cube roots in particular. How many terms are in the expression minus 6x to the power of 4 plus 4x to the power of 3? Okay, so terms, the definition of a term is any variable. Okay, so like x or y, it's any constant, so any number. And it's anything that has a times or divide in between it. Okay, so in this case, this one's pretty straightforward. So this is one term. Okay, that's your first term. And then this is your second term. So this expression has 2 terms in it. 1.7. The surface area of a cube is 750 centimeters squared. The surface area measured in meters squared is... Okay, so when we are converting from centimeters squared to meters squared, what we would usually do is from centimeters to meters. How would we get from centimeters to meters? So if I had centimeters and I wanted to get to meters, I would usually divide it by 100. But now, this is kind of a trick one again. Because it's centimeters squared, it means I have to do it twice. So I have to divide it by 100 and then divide it by 100 again. Okay, to get my meters squared. So whatever number's up there, that just tells you how many times you repeat that. So 750, let's see, we're going to go 750 divided by 100. So again, you have a calculator, but let's just make sure we can do it. So that would be 1, 2, so that's going to be 7.5. And then we have to divide it by 100 again. And that's going to be 1, 2. So we're going to end up with 0.075 meters squared. Yeah, that's right. Okay, 0.075 meters squared. Okay, so they do like asking this one quite a lot. If it's centimeters squared to meters squared, you just remember you have to do whatever process you would have done, you do it twice. Okay, same thing if it was meters cubed, you would do it 3 times then. Let's have a look at question 1.8. Okay, 1.8, in the right angle triangle ABC below, AB is equal to BC. Okay, so they've shown us this already. So they said this line here is equal to this line. Why that's important is whenever they tell us this in a triangle, that means that this angle A is equal to that angle C. Okay, the size of angle C is, okay, so essentially what we've got is we've got this triangle. They tell us here we've got this angle is 90 degrees and those two angles are equal. So angles in a triangle also add up to 180. So let's go 180, take away that angle B, which is 90. Okay, so this is going to be 180, take away 90. So we are left with 90 degrees. And then that 90 degrees is A and B. So also A plus C. So angle A and angle C add up to 90 degrees. We know that they are the same, they are equal. And so we're going to just say they are each half of 90. So C is going to be 45 and A is also going to be 45. Okay, because then together they add up to 90. And in total then we've got 45 here, 45 here, and so they all add up to 180. Okay, so the size of angle C is 45. Then we've got a multiplying question with decimals. We have calculators, but let's check that we can do it without the calculator. So let me get a different color quick. My trick for decimals is I underline, okay, so this one has 2 decimal places, that one has 1 decimal places. So at the end, I want to have 3 decimal places in my answer. I'm not going to bother multiplying with these decimals because it's too difficult. So I'm just going to take, okay, 15. I'm just going to take that and I'm going to take the 3. So 15 times 3. Okay, which is, we know it's pretty easy, it's 45, but let's check. 3 times 5 is 15. Carry the 1, and 3 times 1 is 3, add the 1 is 4, so 45. Then, remember we've got 3 decimal places that we need in the answer. So that means we've got to put 3 decimal places here. So it's going to be 0.045 so that we have those 3 decimal places. Okay, so our answer is going to be D. Remember, check yourself on the calculator, you do have it. And then 1.10, which number is missing in the number sequence below? Okay, again, number sequences you got to check. So do we have square numbers? So 1 squared is 1, 2 squared is not 1. Okay, so it's not squares. So let's cross that out. Let's see, is it cubes? So 1 cubed is 1, 2 cubed is 8. So no, not cubes. Can we add something? So let's see, 1 add nothing is 1, 1 add nothing is 2, no. This one, you're going to start to recognize these kind of patterns is actually you add the 2 numbers before to get the next number. Okay, so let's test. So 1 add 1 will give me 2. Then 1 add 2 will give me 3. 2 add 3 will give me 5. 3 add 5 will give me 8. And then 5 add 8 will give me 13. So you add the 2 in front of it to get the number. Okay, so the missing number then is going to be 5. Okay, that is all of our multiple choice questions. We are going to head into some of the working out questions now. Okay, so question 2, we need to complete these. This is kind of just testing your basics. Okay, so 0 divided by 7. Okay, so this one they are testing that you know that anything. So if you have 0 over 1,000, 0 over a, doesn't matter. Anything with 0 at the top is just 0. Okay, because it is, if you had a cake with 7 pieces and you've got 0, it's still 0 even though it's 0 out of 7. And then the next one, a half to the power of 3. So what they are testing is that you can do, okay, so we can just go, we could say the top part, so 1 to the power of 3 and 2 to the power of 3. So we can put that exponent into the brackets like that, and then we can work it out. So 1 to the power of 3 is just 1, and then 2 to the power of 3 is 8. Okay, so 1 over 8 is our final answer. Write 12,000 in scientific notation. So scientific notation, what we need to remember is they want one number and then decimal place. Okay, so what we would do is we're going to say, okay, 1, 2, 3, 4. So I want that decimal place after the 1. So it's going to be 1.2. We don't need to write all those zeros. You can, but I mean, we're trying to simplify it. And then, so how many spaces did I move it? So 1, 2, 3, 4. So it's going to be 1.2 times 10 to the 4. Next up, write down the lowest common multiple of 12 and 48. Okay, so multiples of 12 and 48. So what I would be doing is I'm going to be writing down what are the multiples of 12 and then what are the multiples of 48, and we're going to see what is the lowest common one. Okay, so multiples of 12, that's the 12 times table. So 12, 24, 36, 48, 60. Okay, that's probably fine for now. Multiples of 48 is going to be 1 times 48 is 48. And actually, we can keep going, but we can stop there. So the lowest common multiple is the lowest number that's in both of their times tables. So we can see the lowest number in both of them is going to be 48. So we can then say the lowest common multiple is 48. Write down all the factors of 28. So factors, I always try to remember factors for inside. Okay, so factors of 28. So we can go 1 times 28. We can say 2 times 14. 3 doesn't go in. 4, we can say, so 4 times 7. 5 doesn't go in. 6 doesn't go in. That's all of our factors there, okay? So those are all our factors. So you just test all the different ways that you can make 28. Then they say write down the prime factors. So our prime factors are all the factors that are prime numbers. So remember, prime number is not 1. Prime number is 2 and 7 in this one. Okay, so prime numbers are numbers that can only be divided by themselves and by 1. Okay, so just 2 and 7. Question 2.4. Calculate the average speed of a car that traveled 720 kilometers in 6 hours. Okay, as soon as you see this average speed, you need to remember this formula. So speed, probably done this in science as well. Speed is distance divided by time. Okay, so here we've got the distance is 720 kilometers. Make sure you keep your units so you know what's going on with them. And then 6 hours. Okay, so we're going to go 720 divided by 6. Okay, 720 divided by 6 is going to give us 120. And then it's always the top units, so kilometers per hour, which makes sense because that's what we drive in. So that would be a car speed. Okay, fill in the missing number in the sequence below. Okay, so remember we always test. Is it a square? It's not a square. Is it cubes? These are not cube numbers. So next thing we're going to test is, can we add anything to get to the next one? It's a little bit confusing with the minuses here, but same kind of thing. So we're going to go, if I had -1 and I wanted to get to -4, am I going to add or take away? So I'm going to have to take away. So I'm going to actually take away 3. So -1 minus another 3 will give me -4. Let's test that keeps working. Yeah, still works there, and it still works there. So we're going to go -7, take away 3 is -10. Okay, let's have a look at question 3. So we've got lots of working out questions here. So obviously you have a calculator so you can check your answer, but they want to see all your steps. So first of all, let's just get rid of some of these brackets here. So -4 minus -2. So that becomes a plus. So a minus and a minus makes a plus. So +2. And then we've got plus and a minus. So that makes a -3. And a plus and a minus makes a -4. And so we're going to end up with -4, add 2, which is -2. Take away another 3, which is -5. And take away another 4, which is -9. Okay, remember, if you're struggling with this, with the subtractions, use a number line. Okay, so you would draw your number line and count back. Okay, so you could say we start off with -4, then we add 2. Okay, so then we get to -2, and then we take away. Okay, so you can count back on it literally like that. Okay, if you are struggling with these kind of questions. Next up, we've got a fractions question. So we need to write our answer as a mixed number, but first of all, we can't do any sort of fractions if they're in this form. They need to be improper fractions. So first step is, let's get them into improper fractions. So how we do that is, we are going to look at this 3 and 2/3. how you get an improper fraction is you're going to go the big number times the bottom number. So 3 times 3 is 9. And then we add the top number. Add 2 is 11. And the bottom stays the same. So 11 over 3. Okay, so it's looking a little bit better now. We've got 11 over 3 minus 7 over 12. We can't do subtraction unless the denominator of the bottom number is the same. So we are going to convert this 11 over 3 into an equivalent fraction. Okay, so that's your second step. So we need an equivalent fraction. So 11 over 3, I want it to be something over 12. Remember from our equivalent fractions before, do exactly the same to the bottom and the top. So 3 times 4 would give me 12. So at the top, exactly the same. 11 times 4 will give me 44. Okay, and then we've got 44 over 12, take away 7 over 12, which is going to, remember when we're subtracting, the bottom stays the same. So the top 44 take away 7 is going to give us 37 over 12. Then the final step is they want it as a mixed number. Okay, so that is our final step. We've got to convert it back. So 37 over 12, what you're going to do is you're going to say how many 12s go into 37. Okay, so 12 goes into 37 3 times. There's 1 left over out of 12. Okay, the bottom always stays the same. So that is our final answer there. Okay, so you can see lots of working, but it is a 4-mark question. Then 3.123, again, they've got some multiplying. We can't work with it when it's in this form. So first step is always, let's get into improper fractions. Okay, so we're just going to convert this one. So 1 and 2 over 3. Following exactly the same method we did before. So we times the bottom and then add the top. 1 times 3 is 3. Add 2 is 5. And the bottom always stays the same. So we're going to have 5 over 3 times 5 over 6. And then multiplying is really straightforward with fractions. You just go top times top. So 5 times 5 is 25. And bottom times bottom. 3 times 6 is 18. And again, they want it as a mixed number. Okay, so our final step is always converting it back. So how many 18s go into 25? So 18 goes into 25 one time. And then let's check how many remainders. So it is 19, 20, 21, 22, 23, 24, 25. So remainder 7. So we're going to have, it goes in one time, there's 7 left over, and the bottom always stays the same. Okay, one more fraction question to go. So 3.1.4, we've got a division question. So you've always got to try to remember the KFC. So when we're dividing, we keep the first term. So we keep 2 over 5. We flip the second term. Okay, so this is keep. Second one is flip the second term. So that second term, we turn it upside down. So it's going to be 2 over 1. And then we change the sign. So instead of divide, we're going to times it now. And then nice and straightforward, we're going to go 2 times 2 at the top is going to give us 4. And at the bottom, 5 times 1 is going to give us 5. And that is as far as we can go. It is not an improper fraction, so we don't have to change it. So that's all we need to do. 3.1.5 is a percentage question. So how I would work out percentages usually is, let's see, 4% of 500. So I always say for this percentage symbol, what you need to remember is percentage means divided by 100. It kind of looks like a divide symbol. So 4 divided by 100, and then of means times. So we're going to go times 500. Okay, you can plug that into your calculator then. So we're going to have 4 divided by 100 times 500. And we get our answer is 20. Okay, carrying on, let's have a look at 3.2. So 3.2, my balance is 2,000 Rand. What will the new balance be if I withdraw 600 from the account in each of the next 3 months? So withdraw means I subtract, so minus. So I've got 2,000 Rand. I'm going to subtract 600 Rand for 3 months. Okay, so I'm going to say take away 600 in this month, in next month, and in the next month after that. Okay, so let's see. 2,000 take away 600 is 1,400. Take away another 600 is 800. Take away another 600 is 200. Okay, so you can show this, you can work this out on your calculator. You can work this out using the column method, whatever's easiest. Okay, next up we have got Peter ate 1/5 of his 250 Smarties. How many Smarties were left? Okay, so how we work out 1/5 of 250? So 1/5 of 250. How you work that out is you always divide by the bottom number times by the top. So let me just put that next to it. So you divide by this 5 and you times by the 1. So we're going to go 250 divided by the bottom number times by the top number. So 250 divided by 5, or if you think of 25 divided by 5, is going to be 50, times 1 is just going to be 50. Okay, so that is how many he ate. So he ate 50 of them. So how many are left then? So he had 250, he ate 50. So there are going to be 200 left. And then calculate how much interest Mr. Jones owed if he borrowed 10,000 Rand at 15% per annum simple interest for a period of 3 years. Okay, so what you would work out here is you are going to say 15% of 10,000 Rand. Okay, so again, remember we say 15. That percentage sign means divide by 100. 15 divided by 100 times 10,000. Okay, 15 divided by 100 times 10,000 gives us 1,500 Rand. So that is his interest for 1 year. We want it for 3 years. Okay, so 3 years means we are going to go that 1,500 for 3 years times 3. And so we're going to end up with 4,500 Rand interest is what he owes. I'm going to make another video with the rest of the questions. I hope these helped so long. Please let me know if you have any comments or any questions.